Through Time, where we explore the concept of atoms evolved from ancient Greek to the present. Atoms make up every single thing in the universe, but our understanding of what an atom is has evolved significantly over time, and it all started thousands of years ago with an ancient Greek philosopher called Democritus.
He was first to propose that matter was made up of fundamental invisible particles that could not be broken into pieces, which he called atoms, meaning uncountable in Greek. His model was a sphere with no electrons, protons, or neutrons, though this was more of philosophy than real science with no supporting evidence gathered. Until fast forward to the 1800s, when John Dalton developed Democritus' ideas and provided the first empirical evidence that atoms exist. His theory emphasized that compounds consist of different atoms that cannot be subdivided, created, nor destroyed. He also said that the atoms of the same element were identical on the mass, size, and other properties, while atoms of different elements also have distinct properties. He stated that the chemical reaction involved in the rearrangement of atoms in whole number ratios to form new combinations.
This view changed in 1897 with J.J. Thomson, as he showed that atoms must consist of smaller particles when he discovered electron. In his cathode ray experiment, particles were ejected in neutral material and shown to have negative electrical charge since they were attracted to positively charged metal plate, which means instead of atom being a single thing, they were balls of positive charged spheres that had negative electrons embedded within them like plums in a plum pudding, hence he called this plum pudding model.
In 1909, Ernest Rutherford carried out the gold foil experiments where he fired tiny positively charged alpha particles at a piece of very thin gold foil. He observed that the most of the alpha particles passed straight through the gold foil, showing the atoms are mostly empty space. However, small percentage of the alpha particles were deflected with the high energy in the random directions, indicating the presence of the concentrated positive charge at the center of the atom, called the nucleus. In this observation, the alpha particles were aligned with the nucleus, causing the repulsion between the positive charges, making them deflect in the random direction. This discovery led to identifying the proton, the positively charged particle within the nucleus.
The next development was in 1913 with Niels Bohr. He refined the nucleus model, specifically the area containing the electrons around the outside. He discovered that electrons didn't just orbit the nucleus randomly, but instead at specific distances where some were close and some were far. He proposed that electrons move around the nucleus in fixed orbits or shells, known as electron shells or energy levels, where a shell closest to the nucleus has lower energy, while the farthest has the highest energy. And if an electron jumps between these energy levels, it would absorb or emit discrete amount of energy, maintaining atomic stability.
Fast forward in 1932 with James Chadwick, where he fired alpha radiation at beryllium sheet from a polonium source, leading to a production of uncharged, penetrating radiation which consisted of uncharged particle approximately having the same mass as a proton. These particles deflected neither in electric nor magnetic field, so they bore no electrical charge. These particles were later termed neutrons. This journey through time has brought us closer to unraveling the history of building blocks of the universe.
Remember, every object you see, every breath you take, is the result of the incredible journey of the atoms that make up our world.